Hello everyone. A very good evening. We will start the session within 5 minutes. Let's wait for everyone to join in. Okay, so let's start the session. So, hello everyone, a very good evening. My name is Pooja Verma, MPM Research Scholar from IIT Kharagpur, and instructor for this course is Dr. M.K. Bhuvan, Department of Electronics and Electrical Engineers, IIT Guwahati. This is a week 10 live and interactive session on computer vision and image processing, fundamentals and applications. So, I hope all of you have gone through this week video lectures, and any one of you can confirm it once whether I am audible and visible. Okay,
Yes, ma'am. Audible.
okay, sure.
Audible, ma'am.
Yeah, okay. So you can use chat box for asking and interacting. So please try to make it interactive. So we will move to the questions. This is our course layout. So this is a week 10. So in week 10, we will go through the some questions based on the fundamentals of machine learning. Okay. So this is our first question. So our first question is, in the context of linear discriminant analysis, LDA, which of the following best describes the objective function for finding the optimal projection? Option A, maximize the sum of variance of all classes. Option B, minimize the distance between the class means while maximizing within class variance. Option C, maximize the ratio of between class variance to within class variance, or minimize the total variance of the dataset. Which option can be a correct one? First, you will try to give answer for this question. Then we will go through the explanation, detailed explanation. Okay, Anand is saying option B. Sorry, option C. Yeah. Okay. What about others? Okay. So option C. Everyone is it. Okay. So let's see. The detailed explanation is here. So in linear discriminant analysis, that is a LDA, is a supervised dimensionality reduction technique which aims to project data into a lower dimensional space while preserving as much as possible class discriminatory information. So our option, we will go through the option wise. So our option A is maximize the sum of variance of all classes. So this is a not the goal of the LDA because the simple maximizing of variance across all the classes that does not guarantee that those classes will be separated from each other. So that might be increase the overall spread of the data. So this is a not a correct answer. And option B is minimize the distance between class means while maximizing within class variance. So this is the exact opposite of what LDA attempts to do, or that goal of the LDA. So that minimizing the distance between means and maximizing within class variance would lead to maximum overlap and that poor class separability that will not separate all the data points clearly. In contrast, it will merge all the data points. Okay, so this is also not a correct option. Now, next option is option C, that is a maximize the ratio of the between class variance and to within class variance. So we can represent the LDA to find the projection direction that maximizes the Fisher criteria, that is Fisher discrimination criteria. So that criteria is defined as the ratio of the criteria is defined by this equation. Okay, that is a ratio of the between class variance, that is a SB, that measures the separation between the different class means, and to the within class variance, that is called SW. This is that measures the spread of the data points within a class, within each class, and that maximizes this ratio. And LDA ensures classes are as far apart as possible while being the compact as possible within themselves. So mathematically, it is represented by this formula. Okay, so yeah, this is the correct option for that. Let's see the last option, what it is saying. So minimize the total variance of the data set. So minimizing the total variance is not a standard objective for the LA and the PCA. By contrast, that is principal component analysis, by contrast, focusing on maximizing total variance to preserve as much information as possible, but it does so without considering class level. So the correct answer for that question is maximizing the ratio of the between class variance to within class variance. Okay, so option C is the correct answer for this question. Yeah, most of you have given the correct answer. So is it fine to all of you? Can we move to our next question? Okay, so moving to our next question. Now next question is using least square regression for the following set of points. So these are the set of points that are given. So they are asking find the estimated value of y for x is equal to 10. So now we need to find the value of y for x is equal to 10. So anyone have any idea how we can solve this question or how we can proceed with this question? Okay, so let's see the solution. I will solve it here. First, yeah. So to find the least square regression, we need to fit the straight line equation, that is to find the least square regression line by y is equal to mx plus c, as we know that. And by this formula, we can find the slope of the line, right? The slope m is calculated by x by minus summation of x and summation of y divided by n summation of x square minus summation of x whole square. We can calculate the slope using this formula, and the intercept is calculated by the intercept, that is c. C is summation of y minus n summation of x, that means all the data points, by n, right? Now the data points are given. So the data points are 1, 2, 2, 3, 3, 5, 4, 5, and 5, 6. Right? So there are 5 data points, right? 1, 2, 3, 4, 5. The total 5 data points are there. So n is equal to 5. That are total data points given. So first we will do this is a x coordinate, this is a y, right? Similarly for each data point it is. So for summation x, we have to add or we have to sum all the data points that corresponds to the x direction, right? So 1 plus 2 plus 3 plus 4 plus 5, right? So if you add all these data points, you will get here 15, right? And now similarly, we have to calculate Thus for summation y as well. So any one of you can calculate and let me know what will be the summation y. 20. Yeah, right. Yeah. So y is 2 plus 3 plus 5 plus 4 plus 6. Right? If you add all the data points, you will get 20. Now, similarly, we need to find out summation of x, y, right? So it is a simple multiplication. What will be the 69? Yeah, correct. So xy is summation of so 1 into 2 plus 2 into 3 plus 3 into 5 plus 4 into 4 plus 5 into 6. So if you add all those data by multiply and add 2 plus 6 plus 15 plus 16 plus 30, right? So if you add all these, so you will get 69. Yeah, okay. So we have calculated summation x, summation y, and summation xy. I'm just writing it here to remove this. We have got 15. Summation y we have got 20, and summation xy we have got 69. Okay, so I'm just removing it from here. So now next value what we need to calculate? Summation of x square, right? This part. It's 55. Yeah, correct. So x square. So 1 square plus 2 square plus 3 square plus 4 square plus 5 square. So that means the square of all at the x point. Okay, so you will get 1 plus 4 plus 9 plus 16 plus 25. Right? If you add also you will get 55 here. Now we have got all the points or all the computations, so we can put it in the slope formula. So m is equal to, so it is a n is 5, it is a total number of data points, right? So 5 into summation of xy that we have calculated, that is a 69, minus the summation of x into summation of y. So that is 50 into 20, right? Now in the denominator, so 5 into summation of x square, so that we have calculated 55, minus summation of x whole square. So summation of x is 15, so 15 whole square, right? Now if you further multiply, you will get 345 minus 300 divided by 275 minus 225. Okay, so if you just subtract and then divide it, you will get 0.9. Okay, m we will get 0.9. Yeah, correct, Priya. Now similarly, we have to calculate for the intercept. Okay, so I'm just removing it from here so that we can calculate the intercept. So m that we have calculated, that is a 0.9, right? Now we will calculate c. So c is summation of y, that is a 20, minus m that we have calculated 0.9, and summation of y is 15, right? And n we know that that is 5. Okay. So now if you further just calculate it. So you will get 13.5 here, 0.9 into 15 and 5. And further, if you subtract and divide it, so you will get 6.5 by 5, that is a 1.3, right? See, anyone have, okay, yeah, right, calculated. Now, what we need to do, now the equation for the list regression line is, as we know that is a y is equal to mx plus c. So just put in the value. So m is 0.9, x plus 1.3, right? And now in the question it is given here, we have to estimate or find the value for of y for x is equal to 10. So here x is equal to 10 is given, so 0.9 into 10 plus 1.3. So here you will get 9 plus 1.3, that is equal to 10.3, right? So 10.3 is the final answer. So y is equal to 10.3 is the final answer. So if you just check in the options, you will get option C is the correct answer for this question. Okay. Is it fine to all of you? Any doubt? Can we move to our next question? Okay, so I hope all of you have understand. Now moving to our next question. Now our next question is, in a linear SVM, if you remove a data point that is not a support vector, how does the decision boundary, that is a hyperplane, change? Option A, it shifts toward the removed point. Option B, it rotates to maintain the maximum margin. Or option C, it remains unchanged. Or option D, it disappears. Which option can be a correct one? Okay, many of you have given answers. That is option C. Okay, okay. So let's discuss in detail so that others can understand. So here detailed explanation options by options is given here. Our option 1A is it shifts toward the removed point. So this would only happen if the removed point was a support vector. If removed point is not a support vector, then that does not change. So that was pushing the boundary away. So this is a not our correct option. Now our option B is it rotates to maintain the maximum margin. So the margin is already maximized related to the support vectors, and removing as a non-support vector that does not provide a better way to rotate the plane. So that is also not on our option, not a correct option. And option C is it remains unchanged. In a linear SVM, the decision boundary, that is a hyperplane, is determined slowly by the support vectors, the point closest to the margin. So non-support vectors are the data points that lie outside the margin, and the optimization process of finding the maximum margin ensures that these points don't influence the position of the hyperplane. So that's why if the data point is not a support vector and it is removed, the support vector and the maximum margin that define remains the same. It does not change. So it remains unchanged. So option C is the correct option for the given question. And let's check for the option B also, it disappears. So the hyperplane is a mathematical solution to an optimization problem. So it exists as long as there is a data to separate. So it will not disappear. The correct answer is option C, that is it remains unchanged. Okay. So most of you have given quite the answer for this question. So now I hope all of you have understand this question. So now moving to our next question. So our next question is, consider the three-dimensional normal distribution. Okay, where mu, the mean vector, is given and the variance vector is also given. Now they are asking for find the probability density at the point x, that is x point is given 0.5, 0 and 1, that x vector that is given. Okay, so now here the distribution that is given, that is a normal distribution. Mean and variance vector is also given. We need to find for the given point theta vector. So how we can find it? That is a covariance matrix is given. Anyone, any idea how we can solve this question? Okay, so let's solve it. So to find the probability density at a specific point, like x, the given vector, so to find the probability density at a specific point for a multi-class or multivariate normal distribution, the formula is P of x, that is the probability of x, 1 by 2 pi k by 2, 1 by 2 exponential of minus 1 by 2 x minus mu transpose, inverse of covariance matrix, and x minus mu. So this is the formula to find the probability density function of the at a specific point. Okay, so here it is given as it is a three-dimensional normal distribution. So here k represents the dimension. Okay, so here k is equal to 3, that is a three dimension given, and mu is our mean vector and this one is our covariance matrix. So first we need to calculate x minus mu to calculate the whole equation. First we will calculate x minus mu. Okay, so x that is given as 0.5, 0 and 1, that is minus of mu mean vector, that is a 1, 2 and 2. So that is equal to minus 0.5, minus 2 and minus 1, right? Okay, so now what we need to do, we need to find out the inverse. What we need to do, first we need to determine the determinant of this covariance matrix, right? So to determine the, so first the inverse, so determinant of that is covariance matrix, that is a sigma. So if you directly see that in this covariance matrix, this one, this matrix, so if you just calculate, so only 2 cross 2 matrix only give the determinant because these two values are 0. So if you calculate, that will be the, so 1 into 5 into 5 minus 2 into 2, right? And all these values you will get 0 only. So here you will get 25 minus 4, that is multiplied by 2. So total value here, the determinant of this covariance matrix, you will get 21, right? Is it fine till now? Then now we need to find out the inverse of the this covariance matrix. Now, so to find the inverse, that is a, so this is a because of this block structure, right? So what we need to do in the 2 cross 2 matrix, if you find the in the 2 cross 2 matrix inverse, so it is a 1 by determinant, right? It is 1 by determinant, and this A, B, C, D values is, so it will be the changed, right? And it is in the minus and minus. So here these values are 0. So this is as a block structure, right? So if you just if there is any, so it is not possible all the values will be 0. So we can directly calculate. So 1 by 21, that is a determinant 1 0 0. Here it will be the same, and here it will be the 5 because the values, these values are also same. So 5 and 5 here, minus 2 and minus 2. We will apply in the 2 cross 2 matrix because this is like a block structure and values are also identical, and these values are 0 if you see that, right? So that's why. So directly we can find, otherwise you can just calculate the inverse for each matrix, that adjacent matrix, right? So I can directly write it here, just removing this one, the inverse of the inverse matrix 1 0 0. You can calculate it also by yourself. 5 by 21, if you multiply that inside, minus 2 by 21, minus 2 by 21, and 5 by 21. Okay, so this matrix you will get the inverse of this one. So now what we need to do, so just removing all these points here. So is it fine till now? I'm just removing the other parts. Is it fine? Or you want to note down something? Okay. So what I can do, I can take one extra slide. Okay. So now we have got the inverse matrix and the x minus mu also. So directly we can compute this part, right? X minus mu transpose inverse covariance matrix inverse and x minus mu. So here for that we will get minus 0.5, minus 2 and minus 1, right? And our inverse covariance matrix is 1 0 0 0 and 0, 5 by 21, minus 2 by 21, here minus 2 by 21, and 5 by 21. And similarly then again this minus 0.5, minus 2 and minus 1. Now multiply the each matrix row by column. So what you will get? So first we will multiply these two. So minus 0.5, minus 2, minus 1. And here if you multiply, so minus 0.5 and all the other values will be the 0, and in the next this row to this column, so here you will get minus 10 by 21, so 5 into 2, right? And here minus minus will be plus, so plus 2 by 21, right? Similarly in the for the third row, Here you will get 4 by 21 minus 5 by 21. Okay, so I just little bit I'm just calculating this part only, then we will multiply this part only, so minus 0.5, and here if you just add it, so 8 by 21 you will get, and here minus 1 by 21, right? With this one only. This is a simplified part of this. Okay. So now what we need to do, just multiply these two matrices. So I'm just writing the final 0.5 minus 2 minus 1, that is multiplied by minus 0.5 minus 8 by 21 minus 1 by 21, right? So now if you further just multiply, so you will get 0.5 minus 0.5 whole square. Here minus minus will be the plus, so 16 by 21, and here again plus, that is plus, yeah, 1 by 21. So now you just 0.25 plus 17 by 21. Okay, so now if you further divide it and just add it, you will get 1.0595. Okay, so is it our this whole part? Now we have calculated, so now we can put in this formula. Just a minute, I can have this working. So is it fine till now? Can you put in this that formula that we have given previously and calculate in this formula this one and calculate the overall value? Now all values we know. Yeah. So p of x, that is given data point, so the value will be 2 pi by k by 2, right? Our formula is k by 2. Then covariance matrix, determinant of the covariance matrix by 2, and exponential of minus 1 by 2, and this whole part x minus mu transpose inverse x minus mu. Okay, so 1 by 2 pi, here dimension is our 3, so 3 by 2, and our determinant for this matrix was 21, right? That determinant, yeah, 21, this one, and this is a root 1 by 2, so it can be written as a root 21, right? Now exponential of this part, so this part we have calculated, that is a minus 1 by 2 multiplied by 1.0595. Okay, so now if you further just calculate this value, you will get, that is a 15.749, and root 21 if you calculate you will get 4.5826, and exponential of that you will get minus 0.5297. Okay, so now if you further multiply you will get 72.17, and this exponential of this value you will get 0.5887. Okay, now further if you divide it and just writing it here, this part for final solution. So if you just divide and multiply it, you will get 0.0087. 0.157. So there is some, I mean, you can take the 0.0081, that is approximately that is equal to 0.0091. Okay, which is given in the option. So if you just there is some, I mean, exact, or there is 0 point some values if you take, so you can get it. That is approximately equal to 0.0091. So for that, the option 4 is the correct answer for this question. So is it fine to all of you, or you have any doubt? Okay, so can we move to our next question? Okay, so now moving to our next question. I hope all of you have understand how to calculate and you can able to calculate these questions. Okay, so now move to our next question. Our next question is a discrete random variable x has two possible outcomes, that is 0 and 1, with probabilities, that is probability of x is equal to 0 is 1 minus theta, and probability of x is equal to 1 is theta. So given a five independent observations, so these are the five independent observations are given. What is the maximum likelihood estimate of theta? What would be the maximum likelihood estimate of the theta? So anyone have any idea how we can solve this question? Okay, so let's solve this question. So here, since x is a random variable with the probability of x is equal to 1 is theta, and the probability of x is equal to 0 for 1 minus theta, the probability mass function for the or the likelihood function to estimate theta is L of theta, that is represented by L of theta, that is a theta of k 1 minus theta n minus k. Okay, here n is the independent observations, or you can say the total number of samples. N is the total samples, and k is the number of ones in the sample. Okay, so this is a total number of sample and k is the total number of ones. So here n, that is given, 5 samples are given, right? 5, and k, there are number 3, 3 ones are there, so k is equal to 3, right? So now we can put in this likelihood function, the L of theta is equal to theta to the power k, that is 3, right? And into 1 minus theta, that n minus k, so 5 minus 3, right? So theta to the power 3 and 1 minus theta square. Okay, so now we need to find theta 2. For that we need to maximize L of theta. Okay, so to find the theta that maximize L of theta. So for that we take the natural logarithm. Log for log likelihood. So by taking the log, so natural ln L of theta, that is equal to 3 ln of theta plus 2 ln 1 minus theta, right? By taking log both sides. So we can write it like this. Is it fine to all of you? We can write it like this. So I hope it is fine to all of you. So now we need to take the derivative with respect to derivative with respect to theta and set equal to 0, 0 and okay. So d by d theta ln L of theta, that is equal to 3 ln theta will be the 1 by theta. If we take the derivative, so ln theta will be the 1 by theta. Similarly, if we take so this side also 2 by 1 minus theta, and there is also theta one term more, so minus theta. So if we just divide and take a derivative minus theta, so minus sign will be there, right? So it will become the minus. So minus 1, so minus sign will be appear here. Okay, that is equal to 0. So now 3 by theta, that is equal to 2 by 1 minus theta, right? So now just take, so 3 1 minus theta is equal to 2 theta. So after that I'm just calculating it here. So if you just 3 minus 3 theta, that is equal to 2 theta, right? So 3 is equal to 5 theta, and here theta will be 3 by 5. Okay. And now if you just calculate theta is equal to divide it, so you will get 0.6. Okay, so the value of the maximum likelihood estimate of theta will be the 0.6. That is the final answer. Theta is equal to 0.6. So is it fine to all of you? Have you understand this question? Is it fine? Can we move to our next question, or you have any doubt? Okay, I hope all of you have understand this question. So now moving to our next question. So our next question is a discriminant function, that is g of x, classifies a sample into class 1 if option A is equal to g1x is greater than g2x, or option B g1x is less than 0, or option C g1x is equal to g2x, or option D g1x is minimized. Which option can be a correct one? Just waiting for your answer. Can you answer for this question? The discriminant function g of x classifies a sample into class 1. Which option can be a correct one? Okay, option 1. Option is same. Okay. So yeah, this is a basic question. Question to others. Can you answer for this question? So then we will go to the detailed explanation. So let's see. The detailed explanation is here. So a discriminant function that is a g of x, or you can represent the gi of x if there is a multiple classes or multiple points are there, data points are there. So is a scalar function that is associated with the specific class, that is a omega I, that I represents the different classes 1 to n. So for a multi-class problem, if we defined a set of functions that is g1x, g2x to till gcx, where each function represents the score or membership affinity of a feature vector to represent to that particular class. Okay, so the classification decision that is based on the finding the maximum value among all variables that available discriminant function. So for a two-class problem that involves class 1 and class 2, the classifier assigns a sample x to class 1 if value of the discriminant function for class 1 is strictly greater than the value for a class 2, that is g1x, if g1x is greater than to g2x, and conversely if it assigned to class 2 if g2x is greater than to g1x. And if given x is equal to g2x, the point lies on the boundary, decision boundary, that means. And the classification is typically undefined and assigned arbitrary in that case. So here our option A is g1x is greater than g2x. So this is a correct. So this is a standard decision rule for the maximum likelihood and Bayesian classification. If class 1 is greater than to class 2, then g1x would be greater than to class g2x. And our option B is g1x is less than 0. So this is incorrect. So while some specialized function like singular linear discriminant that uses the threshold of 0, and in that case the comparison between two distinct functions requires comparing their relative values. Okay, and g1x is equal to g2x, that is defined by the boundary where the classifier is uncertain. So this is also not a correct one. So g1x is minimized, so discriminant functions are designed to be maximized for the correct class, not a minimized. Okay, so a discriminant function classifies a sample into class 1 if g1x is greater than g2x. So yeah, option A is the correct answer for this question. Okay, so I hope all of you have understand this question. Now moving to our next question. Now next question is class that is omega 1 is randomly distributed, that is mean of 91 and variance is 1, and class omega 2 is also the Gaussian, this one is a Gaussian distributed, and where mean is 102 and variance is 1. If new sample x, that is 100.5, is observed and priors are equal, which class does it belongs to? Either omega 1, omega 2, or both equally, or none. So any one of you can tell. It is a normally distributed, sorry, normal distribution is there. Which option can be a correct one? Anyone? Any idea for this question how we can solve? Okay, so okay, I'm answering class belongs to class. Okay, B. Okay, so let's see in detail. So the both classes are normally distributed, right? With variance, both variance is 1. That is a standard deviation. In the question, both classes are normally distributed with variance, that is sigma square is 1, right? So for the class omega 1, it is mu is 98. We can represent mu 1 and the variance of is 1. And for class omega 2, is also normally distributed. Mu 2 is 102 and sigma is 1, right? So thus since the here also given priors are equal, that is a variance. Since it is given priors are equal, the decision boundary is determined by the mean. By finding the midpoint between two means, where the probability densities are equal. uh, Equal. So the decision boundary we can find mu1 plus q2 by 2, that is 98 plus 102 by 2. So we will get 200 by 2 and over then boundary is 100. So here x, the new sample point is given 100.5. Okay. So if x, that is new sample point, is greater than 100, so sample closer to the mean of, that is, if x is greater than, so that means it is closer to the 102, right? 100. So the sample, or we can directly write it, where the sample it is given 100.5, the new sample point, x is 100.5. So since 100.5 is greater than 100, so the sample, or you can say that the new sample x, that is 100.5, is belongs to, or is, or classified into class omega 2, right? It is a new sample point. Okay, so it belongs to class omega 2. So yeah, option B is the correct answer for this question. So is it fine to all of you, or you have any doubt? Yeah, closest point. Yeah, correct. So is it fine to all of you, or do you have any doubt? Can we move to our next question? Okay, so I hope all of you have understand. So now moving to our next question. Now our next question is, here the probability of x given omega 1, that is the point belongs to class 1, is 0.6, and probability of the class, that is omega 1, is 0.4, and the probability of x given omega 2 is 0.3, and probability of that point is belong to omega 2, that is 0.6. To which class should x be assigned? So to which class x should assign? So anyone have any idea how we can solve this question? So how we can proceed with this question? Here, the probability of the classes and their conditional probability is given. So now the question is has been asked to which class should X be assigned. Okay, so let's see the solution here. So to determine to which class X should be assigned, we will use the Bayesian decision rule. Okay, so to determine to which class X should be assigned, so we use the Bayesian decision rule to maximize the full study probability given by X. Okay, so since probability of X is constant for both classes, we will compare the joint probabilities only. So we can compare the joint probabilities. That is the probability of X given omega I into probability of omega I. So the decision rule states that assign X to omega 1 if that is omega 1 if probability of X given omega 1 probability of omega 1 is greater than probability of X given omega 2 probability of omega 2, right? We have seen this one to the previous one also, or otherwise it will be assigned to 0, right? So first we will calculate the probability of X given omega 1, probability of omega 1. So that is 0.6 multiplied by 0.4. If you multiply to 0.24. Similarly, for the probability of X given omega 2, probability of omega 2, right? So 0.3 into 0.6, that is equal to 0.18, right? So here 0.24 is greater than 0.18, right? Or we can say that I'm just removing it from here. So that means that is probability of X given omega 1, probability of omega 1 is greater than probability of X given omega 2, probability of omega 2. So this joint probability of class omega 1 is higher than the omega 2, then then this X should be belongs to or assigned to class omega 1, right? because it is greater than 2, that probability. So it should be x should be assigned to or belongs to class omega 1. So option A is the correct answer for this question. Is it fine to all of you? Have you understand this question? Is it okay? Any doubt or any problem? Okay, so I hope all of you have understand this question. So now moving to our next question. So our next question is two samples at x is equal to 10 and x is equal to 12. Window with edge h is equal to 4 that is given. Is x is equal to 11 inside the window for both? So they are asking, is x is equal to 11 inside the window for both? The answers in the form of yes, no, or only for x is equal to 10 or only for x is equal to. So anyone have any idea how we can, or it is based on the which concept? Can any one of you tell for this question? Any idea? Here two samples are given and window width is given. And one new sample is given. They are asking whether it is an insight for the given two samples or not. So can you tell it is related to which concept? It is based on the which concept? Any one of you can tell? Okay, nobody is interested to giving an answer. Okay, so it is related to the Pageant window density estimation question. Okay, so in the Pageant density estimation, a point x is considered to be inside the window of a sample xi with width h if the distance between them is less than or equal to half of the window width, that is h by 2. So for any sample, so I'm just writing in Pageant window density estimation. Okay, for any sample that is x of s, the region inside the window is defined by the interval that is xs minus h by 2 and xs plus h by 2. Okay, and where h is the window width. Window width. That here it is given h is equal to 4. Okay, so the given x is equal to 4. So we will put here xs minus 4 by 2 and xs plus 4 by 2. So here we will get xs minus 2 and xs plus 2, right? So now the new sample is also given, that is the xs, that xs is 11, right? So for no, first we need to find out for the both the samples. Just a minute. So for the sample x is equal to 10, first we need to calculate for this sample. So if xs is equal to 10, so 10 minus 2 and 10 plus 2. So the interval will be the What will be the interval? 8 and 12, right? So 8 and 12. So because that new point that is inside the this window in the range of, it is inside the range of, right? So x is equal to 11 is inside the window or inside the range. The window, or we can write it, since 8, the lower bound is 8 and the median, it is in within this range, right? So that's why x is in the inside the window for the this sample, x is equal to 10. Similarly, we need to check for the another sample also. So for sample, the sample x is equal to 12. So for x is equal to 12, what we have, so 12 minus 2 and 12 plus 2. So here we will get 10 and 14, right? So upper bound is 10 and lower bound is 14. So again, it is in this range. 11, the this new is in the inside the range. So for the second window also, so 10 is inside the range. Inside the range, right? So the point X falls within the both the samples. Okay. So the answer is S. So the inside for the both. So I can write it somewhere. So the point X is equal to 11 falls within the both samples. So it is, so answer is S. That is option A. Option A is the correct answer for this question. Okay. So is it fine to all of you? Or you have any doubt? Okay. So is it fine to all of you? Other at least give an answer. Is it okay to have you understand this question? Okay. So I hope all of you have understand. So now moving to our next question. So our next question is here, the three categories of crop heights in centimeter are observed. That is a short, that is omega 1, medium, that is belongs to class another class, that is a omega 2, and then another class is tall. Okay, and the different heights are also given. The data points are given. So three categories of crop height are observed: short, medium, and tall. The question is, assume equal prior probabilities for all classes. If a new plant is measured at 50 centimeter, to which class does it belong based on the minimum error rate? So anyone have any idea how we can solve this question? So here three categories. Okay, Anand is saying it belongs to a medium category. Okay, we will see. Okay, so Let's solve this question. So, to determine the class of the plant that is measured at a 50 centimeter, we need to calculate the likelihood for each category. Okay, so based on the provided sample in the data and select the class with the highest probability. So first, what we need to do, we need to determine the mean and sample variance, right? That is the S square for each category. Okay, so we need to calculate the likelihood for each category. So for this, we need to calculate mean and sample variance because different samples are given. So that is represented by S square for each category. So for first, that is sort, the data points that is given, we need to calculate that is mean, that is a mu n, mu1. So 42 plus 45 plus 48 plus 44 plus 46, right? So how many data points are there? That is a total 5. So if you just add and divide it by 5, you will get the mean for the short category, that is 45. Just you can add and divide it. Now similarly we need to find the variance. Okay, that is a sample variance for this category as well. So variance, or you can say sample variance. Here I am represented it by the S, so S1 square because for the omega category omega n. So how we can calculate? That is calculated by right data point xi minus mu I, right? Summation of xi minus mu I divided by n minus 1. The variance is calculated by, right? S square. So for that we will calculate here. So first point is 42. So 42 minus mu is 45 whole square plus again 45 minus 45 whole square plus 48, next point is minus 45 whole square plus 44 minus 45 whole square plus last one is a 46. So 46 minus 45 whole square here, and that is a 5. So 5 minus 1. So if you further just subtract it, so minus 3 whole square plus 0 whole square plus 3 whole square. So yeah, 3 square, so plus again minus 1 square plus 1 square divided by 4, right? 5 minus 1, so 4. Further, if you just here and just s1 square will be the 9 plus 9 plus 1 plus 1 divided by 4. So here you will get 20 by 4, so 5. So mu1 is 45 and s1 square is 5. We have got. Similarly, we need to calculate for the medium size and tall size as well. So just we can take one more slide. So for the medium or class 2, we need to calculate mu2. So for that, the data points are 52 plus 55 plus 58 plus 54 plus 56. divided by 5, and if you just add and divide it, you will get 55. Okay, just so mu2 we will get 55. Similarly, we need to calculate for the variance. So here S2 square. Similarly, we need to calculate for the same way. So 52 minus 55 whole square plus 55 minus 55 whole square plus 58 minus 55 whole square plus 54 minus 55 whole square plus 56 minus 55 whole square divided by 5 minus 1. Right? Now again we will get minus 3 square plus 0 square plus 3 square plus minus of 1 square plus 1 square by 4. So if you just add, and so here again you will get 5. Okay. Now similarly we need to calculate for tall, that is a omega 3 plus, so mu 3 we will get 65 plus 68 plus 72 plus 67 plus 68 by 5. So here the mean you will get 68 and the variance is 3 square. Similarly, you will get, I'm just directly writing it here, otherwise it is very difficult to calculate all the parts. You can calculate, okay, I can write it. 65 minus 68 whole square plus 68 minus 68 whole square plus 72 minus 68 whole square plus 67 minus 68 whole square plus 68 minus 68 whole square by 4, right? 5 minus 1. So here again you will get minus 3 square plus 0 plus 4 square plus minus 1 square plus 0 by 4. So if you just add it and then divide it, you will get here 6.5. So variance that you will get here 6.5. So now we have got the mean and variance for all the category. So now we need to move to calculate the likelihood for the plant size 50 centimeter. Okay, here it is given. So now can I remove it from here? The all the values already. I hope all of you have noted down. So just removing till here. Okay. Now we need to calculate likelihood for x is equal to 50 centimeter. So we will assume here it is a normal distributed for each class. Assume normal distribution for each class. So probability of x by class 1 by root 2 pi si square, right? e to the power minus x minus mu whole square by 2si square, right? So this is our formula for the normal distribution. So now we'll calculate for each class. So for omega 1, so probability of x by omega 1, here x is 50, right? So I can write 50. So 1 by root 2 pi into 5 e to the power minus 50 minus 45, mu 1 is 45 into 2 by 2 by 5. So now here we will get 1 by root 10 pi e to the power minus 2.5. Now if you just calculate all these values, so you will get that is approximately equal to 0.0146. Okay, similarly we need to calculate for the other two classes as well. So I'm just removing it from here. Okay, so for class omega 2, so probability of 50 by omega 2. So now again 1 by root 2 pi, here the variance we have again got 5, so into 5 e to the power minus, here x is 50 and mu 2 we have got 55, right, by 2 into 5. So again if you just calculate, so here you will get root 10 pi e to the power, so 50 minus 55, so minus 5 minus 5 whole square, right? So again here you will get just calculate 2.5. So this is the same value, so that is also the same 0.0146, right? Now for the class omega 3, so probability of 50 by omega 3, 1 by root 2 pi s square we have got, that is 6.5 e to the power minus 50 minus 68 over the and 2 into 6.5. So here if you just calculate it, 1 by root 13.5 and e to the power minus 24.92. Now if you just calculate, you will get 2.35 into 10 to the power minus 12. Okay, you can calculate it later. I have already calculated. Okay, so the minimum error rate rule assigned to the sample to the class that has the highest likelihood. Okay, so I'm just taking the one another slide. So the minimum error rate rule assigns the sample to the class with highest likelihood. So probability of 50 by the 1 and probability of 50 by for class 2, that is equal, that is 0.0146, right? And probability of the class 3 or 12, that is 2.35 into 10 to the power minus 12. So that is approximately equal to 0, right? Because minus of 12. So and these two classes have a highest probability. I mean that is greater than to the class 3. So the value 50 is exactly halfway between the mu. So the value 50 is exactly halfway between mu1 is 45 and mu2 is 55. So because both the classes have identical variances, that is s1 square and s2 square, we have what equal to 5, right? So their likelihood curves intersect exactly at x is equal to 50. So their likelihood curve intersect exactly at x is equal to 50. So based on the minimum error rate, the plant measured at 50 centimeter falls on the decision boundary. Okay, so and it pretty likely to belongs to a class, to the short class or a medium class. Okay, so the plant measured at 50 centimeter falls on the decision boundary. Centimeter it is. Okay. And equally likely to belong to the short, that is omega 1 class, or medium, that is omega 2 class. Okay, so this is the solution for this question. So is it fine to all of you? Have you understand this question or you have any doubt?
Hello, yes, Anand here, madam. Yeah, I
Okay,
am understand, but I think it's a little bit tough to make it this much calculations. Is there
yeah,
any other option to make it?
okay. So yeah, it is little bit lengthy, but
Just to make it judgment, we can go for a mean what it is for the median or whatever first time. If you go for
okay,
the next variance, it's tough to make it.
okay. But if you don't go by this one, yeah, you can directly calculate from there also and from the mean. But for better clarity, you can go to the, I mean, if you time permit, then in that case to the variances.
Okay, thank you.
So I hope all of you have understand this question. Can we move to our next question? Okay, so moving to our next question. Uh, so yeah, here our next question is related to the PCA. Consider the set of points, that is the set of points that is given 1, 2, 2, 3, 3, 4, and 4, 4, 5. So find the principal component vector for this set of points. So can you find it? How we can find the principal components for the given set of points? Anyone any idea how we can solve this question? Okay, so let's solve it quickly. So to find out the principal component, what we need to do, we need to find the first the means for the x and mean for the y as well. Okay, then we had to make a covariance matrix and find out the eigenvalues and eigenvector then. So they are asking for principal component vector. Okay, so let's first find the mean of a given point. Find the mean of the given points. So for x, x dash, that is a 1 plus 2 plus 3 plus 4, right, by 4. If we just calculate it, we will get 2.5. Similarly for y also, so 2 plus 3 plus 4 plus 5 by 4. If we calculate, so 14 by 4, that is equal to 3.5. So the mean that we have got, the mean vector, we will get 2.5 and 3.5. Okay, so this is our mean vector. Okay, I will share Swati. After completing this, I will share it. Okay. So now we need to find out the center data, right? That is the center data that have been calculated by xi minus x dash and yi minus y dash. Okay. So first we will find the center data for each data point. So for first that is a 1 and 2, right? So 1 minus 2.5 and 2 minus 3.5. So x first data point, this one I'm taking here. So now if you just subtract, so here you will get minus 1.5 and minus 1.5. Similarly for the next data point, so 2 minus 2.5 and 3 minus 3.5. Now again we will get here minus 0.5 and minus 0.5. Now take the another data set, that is a 3 minus 2.5 and 4 minus 3.5. Now the next you will get here 0.5 and 0.5. Next data and last data point is 4.4 minus 2.5 and 5 minus 3.5. So here again you will get 1.5 and 1.5. Okay. So now if you see the all the data points in the data center data, all are identical x and y's, right? So for now, next we need to calculate the covariance matrix from the centered data. So covariance matrix is. So for that we will take here variance of x, covariance of x, y, here again covariance of x, y, and variance of y. Okay. So now if you see in the data points, centered data, all the points are identical, right? Like minus 1.5, 1.5, x and y are the identical in the centered data, all the in the centered data. So variance of x, variance of y, and covariance of xy would be equal because x and y are identical in the centered data point. Centered data point. Okay. So now we need to calculate the variance. If we calculate the variance of any one, then we will get the all the variance of x, variance of y, and covariance of put in this one. So I'm just removing it from here. From here, I hope all of you have noted down. So now we will calculate the variance of x. So it is minus 1.5, right? I have actually removed, so just I am writing. So minus 0.5 plus 0.5 and plus 1.5 square. Okay, by n minus 1. So total data points are 4. N is equal to 4. So here 4 minus 1. Okay, so now if you just take a square, you will get here 2.25 plus 0.25 plus 0.25 plus 2.25 by 3. Okay. If you just add, you will get 5 by 3 and here 1.667. Okay. Now the covariance matrix will be the 1.667. All the values are identical, 667 and 1.667. Okay. The principal component is the eigenvector that corresponding to the largest eigenvalue of the covariance matrix. But here all the values are identical, here equal. So in this type of matrix, so for a matrix where all entries are equal, such that 1.8 or 1.61, here all the values are identical. So the longest or the largest eigenvalue is lambda, that is equal to 2a. So I'm just writing it here. So for a matrix where all entries are equal, such as I'm just taking an example like A, and A. So the largest eigenvalue, its largest, just one minute. So the largest eigenvalue lambda is equal to 2a would be there, and has a eigenvector that is v1 is equal to 1, 1. Okay, so if we see in our matrix that all the values are identical, so our lambda would be, so here lambda would be 2 into 1.667. If you just multiply it, so you will get 3.334, right here. So the eigenvector that we will get from here, so here we will get 3.334 and 3.334. If we take out 3.334, so the eigenvector that we will get 1, 1. And if we just remove the constant part, we will get the eigenvector 1, 1, right? So this 1 and 1. For that, correct answer is V, right? So is it fine to all of you? Have you understand how we can solve this question? Is it fine to all of you? Have you understand? or any clarification is required? Is it fine to all of you? Can we move to our next question? Okay, so now moving to our next question. So our next question is, consider a two-class problem omega 1 and omega 2 with 2D feature vectors. That is, priors probability of omega 1 is equal to probability of omega 2 is 0.5, and probability of the component being 1 in omega 1, that is pi, is equal to 0.8, and probability of component being 1 in omega 2, that is a qi, is 0.4. Now they are asking for find the decision surface g of x. So how we can find the decision surface? For that, anyone, any idea? Okay, so let's quickly solve it because we can. So here for a binary classification, because it is a two-class problem, that is a omega 1 and omega 2, where each component xi of the vector x is a Bernoulli's random variable. So the log likelihood ratio is, so for a binary classification problem, that is the omega 1 or omega 2, we can say two class of problem. So the log likelihood function, log likelihood ratio is, that is a g of x is equal to ln probability of x given omega 1 and probability of omega 1, that is divided by probability of x given omega 2 and probability of omega 2. Okay, so here, since here probability of omega 1 and equal to probability of omega 2, that is equal to 0.5. So the prior term, this part will be the cancelled out. Okay. So for the independent feature of the likelihood is the that product of the individual probabilities. So that g of x can be written by the different I values. So here summation of I is equal to 1 to d, that is a dimension ln. So here we can write it like pi of xi, right, and 1 minus pi 1 minus of xi here, and in the numerator qi of xi 1 minus qi by 1 minus xi. So this is a equation for the individual probabilities. Now further we can just solve it. You can take the another side. So after this we can further solve that equation, that is equal to summation of I is equal to 1 to d, that is if we take log in this one, we take that ln is there, so xi we can apply that log, so ln pi by qi, right, we can write it like this, plus 1 minus of xi ln 1 minus of pi by 1 minus of qi. So this is after taking the log, and then by taking applying the after logarithm natural log. So further we can solve it like this. I is equal to 1 2D, right? X of I in the bracket. So ln pi by qi by taking the xi common here minus ln 1 minus of pi by 1 minus of qi. We are taking common from here xi, right? In the one large bracket here plus ln here one term is left, so 1 minus pi by 1 minus of qi the whole. So we can simplify this to the linear form. This simplifies to the linear form. So gx would be equal to summation of wi xi plus w naught. So here in this equation, what is our wi? Wi is this part, right? Like summation of all ln pi of by qi minus ln 1 minus of pi by 1 minus of qi. Okay, and w0 is this part, and w0 is that is a weight, and this one is a biases ln 1 minus of pi by 1 minus of qi, and there is a summation also, right? So this is the simplified linear form. Now we will put the values in this. So here given pi is 0.8 and qi is 0.4 for all I. In the question itself it is given here for all I. But here two classes are there, so for class 1 and class 2 you can say that. So first we will calculate weight. So wi, for wi we can calculate wi is equal to ln. So here it is wi, so 0.8 by qi is 0.4 minus ln 1 minus 0.8 and 1 minus 0.4. So here ln of 2 minus ln 0.2 by 0.6. Okay, so now further if you ln of 2 minus ln of 1 by 3. Now if you just calculate the value, so you will get here 0.69315 minus of 1.0986. ln 1 by 3 value is minus of 1.09. So now if you further just add, so you will get 1.79176 for the weight. Similarly, we will calculate for the bias as well. So I just am removing it from here. So we will calculate for the bias here, bias that is omega naught. So we will put here. So here two classes are there. So right. So ln two classes are there, for the both classes are the given, all are equal. So summation here I is equal to 1 to 2 ln 1 minus pi 1 minus 0.8 and 1 minus 0.4. Okay, so here for two classes, so 2 it will be the same, so we can directly multiply it. 2 into ln 0.2 by 0.6. So again here 2 into ln 1 by 3, and here 2 into minus ln 1.1 by 3 value is minus 1.0986. So if you just multiply, so here the bias value overall you will get minus 2.1972. Okay. Now substitute this value in the simplified linear form in the gx. So in the gx, we have summation for the all. It is the outside, and now weight. So wi we have got, that is 1.79, and xi is there, and minus 2.1972, the value of the viruses, and that is equal to 0. So this is our, here I is 1 2D, that is a dimension. Okay, so this is our final answer. So let's match with the, so here if you match that, you will get with this one. Option B is the correct answer for this question. Okay, so is it fine to all of you? Have you understand this question? Okay. Any doubt? Any problem? Okay, so I hope all of you have understand this question. Now quickly moving to our next question. So now next question is, which of the following is the characteristic of the non-parametric density estimation method like Poisson window? Option A is, it does not assume a specific functional form like a normal distribution for the whole population. Option B, it only works with the discrete data. Or option C, it requires the calculation of the covariance matrix sigma. Or option D, it is used only for linear regression. Any answers? Okay, option A. Okay, let's see quickly the detailed solution is here. We will move to the options. So yeah, it does not assume a specific function form like a normal distribution for a whole population. A non-parametric method like a Poisson window, also known as a kernel density estimation, that don't assume that the data follows a fixed predefined mathematical distribution such as a normal or Gaussian distribution. So instead of doing that, it estimates a few fixed parameters like a mean and variance, and these methods use data itself to define the shape of the density function and making them highly flexible for modeling complex distribution. So that is the correct answer for our question. Let's move to, we will see the other options as well. It only works with the discrete data. So while some variant can handle the discrete data, but Poisson window are primarily used for estimating the density of the continuous variable, not a discrete. So it requires the calculation of the covariance matrix. So calculating a global covariance matrix is a hallmark for the parametric method like a single multivariate quotient. So Poisson window typically use the kernel or windows function centered at each data point rather than the single global matrix for the entire population. Okay, option D is, it is used only for linear regression. So Poisson window are used for the density estimation, so which can be applied for classification, novelty detection, and various unsupervised tasks, not just a linear regression. So the correct answer is option A, that is, it is not assumed a specific functional form like a normal list for a whole population. So yeah, option A is the correct answer for this question. Okay, so this is a theoretical question. So I hope all of you have understand, and I hope all of you have gone through this type of questions. So now moving to our next question. So our next question is, what happens to the SPM decision boundary if you add a new training point that is far away from the current boundary and clearly inside its correct class region? Option A, the decision boundary remains unchanged. Option B, the boundary set to include the new point as a support vector, the margin width increases. Or option D, the kernel function must be recalculated. Okay, yeah, that's correct. Let's see the explanation quickly. So yeah, so our option A is the decision boundary remains unchanged. So in the support vector machine, the decision boundary, that is a hyperplane, is determined solely by the support vectors, and the data points that lies closest to the boundary are violate the margin. The first one is support vector dependency. So the optimization problem for the SVM only uses the support vectors that define the position and orientation of the hyperplane. And the irrelevance of the distance points, if a new point is added far from the boundary and correctly classified, it does not become a support vector. Since it is not a support vector, so it does not influence the calculation of the maximum margin hyperplane. And this property makes the SVM robust to safe data points and outliers that are far from the decision region. So yeah, correct option is option A. Let's see the other options as well. The boundary shift to include the new point. The boundary only shift if the new point is closer to the hyperplane. That is currently correct current support vectors. If it is falls on the wrong side of the margin, so it will not shift. Okay. So the margin width increases. So the margin is the distance between the two parallel planes defined by the closest point. That is the support vectors from the each class. So point far inside the correct region does not change these closest points. So margin remains the same. And the kernel function must be recalculated. So kernel function is choosing hyperparameter like a linear RVF or polynomial and not automatically recalculated or changed by a single data point. Only the model parameters are updated during the training. So yeah, correct answer is option A. That is a boundary remains the unchanged. So option A is the correct answer for this question. Now move to the our next question. Our next question is using one NN, that means nearest neighbor, with training points 1 good and 5 bad. How is x is equal to 2.9 is classified? Either good or bad or neutral or cannot be determined. Can you quickly calculate and let me know? Okay, so new data point, that is x is equal to 2.9 is given. It is a one nearest neighbor. So to classify point, that is x is equal to 2.9 using one nearest neighbor, we need to determine we need to determine distance from the new data point from each training points. Okay, so distance to the point 1, and that is a good, classified as a good. So here 2.9 minus of 1, here we will get 1.9. Okay, so now similarly we will calculate distance here to 5, that is classified as a bad. So here 2.9 minus 5. So here 2.1. So the nearest neighbor algorithm selects the joining point with the smallest distance. So the then let the training point with the smallest distance. So since 1.9 is less than 2.1, so the point x is equal to 2.9 is classified, here it is, classified as good because it is nearest. So yeah, it is classified as a good. So correct option is A here again. Okay, so now for this week the question has been completed. So thank you everyone. Thank you for joining this session. Now if you have any doubt you can ask. Otherwise we can close the session. Is there any doubt?
Hello, Pooja ma'am. May I know where can I find the existing recording sessions?
So if you had already, I mean, registered for this course, so from the
Yes.
as previously, you can find in the that portal, NPTEL portal, SWAM portal, there is a live sessions are there. Otherwise, I am just
Ah,
uh,
okay.
give me a time. I will paste it here. The link description.
Okay. Thank you.
Yeah, I'm just pasting it here. So I think from here you can just check all the videos and material is there at this link. Is it fine? Swati, are you able to open this one?
Yes.
Okay, so you can save it from here directly. You can access all the video and materials as well. So so yeah, if there is any doubt, if you don't have any doubt, we can close the session. Okay. So thank you everyone. Thank you for joining this session. Now we are closing this session. Okay. Now you can leave the session if you don't have any doubt. If you have doubt, then you can ask. So yeah, thank you everyone. Thank you for joining this session. I'm just closing this session.